Hello everyone, my name is AB and I'm coming your way again with another part of modular arithmetic, which is the second part. In this particular section, we will talk about making modular arithmetic tables. Let's get right into it, shall we? So let's talk about modular arithmetic tables. Modular arithmetic tables are simply tables that are made up of numbers that are then operated with each other to yield answers. And with these tables, various questions are mostly asked to find what to do with the elements of these tables. So let's get right into how to construct a modular arithmetic table. But before then, there are two important things to note in every modular arithmetic table, and these two things are the modulo, or the modular number, which is going to control the construction of the table, and the operation used. The modular number is simply the number which every answer obtained within the table will be subjected to in terms of its modulo. So if we are constructing a table in modulo 5, whatever operation we perform and get an answer, we will use that answer in modulo 5. And then that final answer, when we operate the resulting answer in modulo 5, will now be used in the actual table. And the operation can either be multiplication or addition, depending on which operation you want to use for your table. So let's take an example and see how we can construct tables of modular arithmetic. So let's take this question. So the question says, construct an addition table in modulo 5. Construct an addition table in modulo 5. All right, let's get right into how this question can be solved, shall we? So to construct a modular arithmetic table in modulo 5, you first draw a table and this table consists of rows and columns that are equal to the number of elements in modulo 5. So the number of elements in modulo 5, you can have 0, you can have 1, you can have 2, you can have 3, you can have 4, you can't have 5 or more. So these are the numbers that can be part of this table. So 0, 1, 2, 3, 4. Okay, that ends there. We have 0, 1, 2, 3, and 4. Adding the extensions. So this is an addition table. Okay, so you write your addition sign here, and then you have the column containing the elements in modulo 5 and the row containing the elements in modulo 5. Okay, so this is how you begin with your table construction. Okay, so the first is you perform the operation by putting together the elements of the column and the row. So the operation we'll perform first will be 0 plus 0. Okay, we know that 0 plus 0 is 0. So after we found our final answer 0, it's not really final. What I mean by that is that this table is in modulo 5. So this 0 must now be subject to modulo 5. So we have to find 0 in mod 5. And that is 0. So then our very final answer will be 0. Let us continue. 0 plus 1 is 1, and 1 in modulo 5 will be 1. 0 plus 2 is 2, and 2 in modulo 5 will be 2. 0 plus 3 will be 3, and 3 modulo 5 is 3. 0 plus 4 will be 4, and 4 modulo 5 will be 4. If we study the table correctly, it will be true for this entire column as well, because 1 plus 0 will be 1, and 1 modulo 5 will be 1. 2 plus 0 will be 2. 2 modulo 5 will be 2. 3 plus 0 will be 3, and 3 modulo 5 will be 3. 4 plus 0 will be 4, and 4 modulo 5 will be 4. So we can go ahead and write these numbers here. So let's move on to the other empty boxes. 1 plus 1 is 2. 2 in modulo 5 is 2. 1 plus 2 is 3, and 3 in modulo 5 is 3. 1 plus 3, 1 plus 3 is 4, and 4 in modulo 5 is 4. So this empty box will be 4. 1 plus 4 is 5, and 5 modulo 5 is 0, because 5 divided by 5 will be 0. 1 remainder 0, 1 remainder 0. So the remainder is our focus, as we've discussed earlier. So we have 0 here. So 2 plus 1 is 3. 3 mod 5 is 3. That's why I wrote the 3. Remember to always apply the mode first before you write your final answer. Okay, don't just go ahead and write the direct answer. You need to write the answer in the mode in which you are constructing your table. 2 plus 2 is 4, and 4 in mode 5 is 4. 2 plus 3 is 5, and 5 in modulo 5 is 0, as we've mentioned earlier. 2 plus 4 is 6. Okay, 2 plus 4 is 6, and 6 in mode 5 is 1, because 6 divided by 5 will be 1, remainder 1. So this will yield an answer of 1. 3 plus 1 is 4. 4 in mode 5 is 4, and that is the reason why I wrote the 4. So you always apply the mode. 3 plus 2 is 5. 5 in mode 5 is 0. 3 plus 3 is 6. 6 in mode 5 is 1. 3 plus 4 is 7. And 7 mode 5 is 2, because 7 divided by 5 will be 1, remainder 2. So you have 2 here. Four plus 1 is 5. 5 mode 5 is 0. 4 plus 2 is 6. 6 mode 5 is 1. 4 plus 3, the same as 3 plus 4, which is 7. 7 mode 5 is 2. And 4 plus 4 is 8. And 8 mode 5 is 3, because 8 divided by 5 is 1, remainder 3. So this will be 3. So this is how an addition table is constructed in modular arithmetic. And so I'm sure you are familiar with how to construct a table under the addition sign. Very important. Now with this table, there are various questions that can be asked, and so there is a need for you to be able to answer such questions looking at this table. So for example, looking at this table, I can ask you to find n plus 3 equals 0. Okay, I'm going to ask you to find n. If n plus 3 equals 0, find n using the table. So using the table, we are going to find n plus 3 equals 0. We are going to find the value of n for which n plus 3 equals 0. And this question is very simple. What this question is trying to pose is, we are trying to find a number which, when added to 3, will yield a final value of 0 on the table. Okay, so the first thing you have to do is to replace n with all the possible numbers on the table and find out which one of or which ones will give you 0. So you have to replace n with either 0, 1, 2, 3, or 4. And if any of these gives a final answer of 0, then that is the value of n. So let's start off by looking at what happens when we replace n with 0. So when n is 0, then we will have 0 plus 3. So let's look at the table. 0 plus 3, and the answer was 3. So what that means is that n cannot be 0, because when we replaced n with 0, we did not get the final answer to be 0, but we got 3. Let's find out what will happen if n is 1. When n is 1, then we will have 1 plus 3, and from the table 1 plus 3 is 4. So again, n cannot be 1, because when we replaced n with 1, our final answer was 4, but our final answer must be 0. Let's see what happens when n is 2. When n is 2, then we will have 2 plus 3, and 2 plus 3 yields an answer of 0 in the table. So since our final answer is 0, and that corresponds to the question's final answer, then n must be 2. But we don't stop here, because sometimes modular arithmetic questions like these can have multiple answers for n. So we continue through by trying all the other numbers. From the table, we can clearly see that when we try 3 and 4, it doesn't work. So 3 plus 3 will yield 1, 4 plus 3 will yield 2. So the only value of n for which n plus 3 is 0 is 2. And so always make sure that you perform the investigation throughout before you come up with your final answer. It's very, very important. It's very, very important. Let's look at another example. If n plus 4 is equal to 1, find n using the table. So from here, we can clearly see that when we decide to replace n with all the possible numbers 0, 1, 2, 3, and 4, the only time n plus 4 yields 1 will be when n is equal to, guess it, 2. Because from the table, it is only 2 plus 4 that yields a final answer of 1. Remember, this table is under modulo 5, so everything here is being operated under modulo 5. All the other numbers will not work, but you have to try all of them. Let's try one last example and we'll be through with this session. If 3 plus n is equal to 1, find n. Again, we can see that when we replace n with all the possible numbers, we will have the only instance where 3 plus n will be 1 to be 3 plus 3. 3 plus 0 will give us 3 according to the table. 3 plus 1 will give us 4. 3 plus 2 will yield 0 in mode 5. 3 plus 3 will yield 1. And then 3 plus 4 in mode 5 will yield 2. So n will be 1 because n will be 3 rather. N will be 3. So 3 plus 3 is 1 according to the table. It is very important to go through these questions and try your hands on them. And I sincerely believe that addition tables using modular arithmetic will be very entertaining for you if you decide to change the numbers. The thing about mathematics is if you change the numbers, it becomes more fun. So with the example we've treated, you can decide to construct another table in a different modulo. Let's say modulo 7, modulo 8, or modulo 9, or any number at all, and then begin to ask yourself these questions that have been presented in this particular presentation, or even more challenging ones. And I believe that you will be very, very comfortable with this part of the topic. And so this brings us to the end of the second part, where we are still talking about modular arithmetic tables. In the next part, we are going to talk about the same modular arithmetic tables, but using a different operation. We'll use a different operation, and I believe that you will be very comfortable with that part of the topic as well. Thank you for your time, and I believe I will see you in the next video. Don't forget to like this video and subscribe to my channel. Also share it with your friends, and let me know if you have any questions in the comments below, or send your questions to my email at abthemathtutor@gmail.com. Thank you once again, and I hope to see you. Bye for now.